SCM, Scopus, and Springerlink, IEEE, Compendix. So basically, these are the things that these are the topics we're going to cover. But the major sections we're going to have understanding research and then literature and the literature search. Sorry for the mixed up. So before I move in, I would like to talk on computing. So when we said computing, there are a lot of among students on what a computer science is, computer engineering, software engineering, information system, or information technology. Sometimes you see a lot of students, when you ask them, after graduating as a computer scientist, you ask them, what is computer science? It's very difficult for what computer science. I've seen many, I've interviewed many. So after that, if you even attempt to ask what's the difference between computer science and software engineering, or computer science and information system, information technology, software engineering, you start seeing a lot of issues. That's why I now find it very necessary that before we move in, I have to categorically explain what the computing is, and then we'll now see what are the different disciplines that make up what computing is. So I will take, even if you check textbook, you see a lot of some differences on what the computing is, some computer science, software, but I will stick to SCM curriculum. SCM is the umbrella body that dictates the pace of computing in the world, Association for Computing Machinery. So they dictate the pace of computing in the world. Most of the top universities and most of our universities, even the NUC curriculum on computer science, they derive many of the content from SCM curriculum. That's why I pick SCM curriculum to be my guiding principle on discussing what the computing is and what are the disciplines that make up and computing. So when we say computing, it means anything that has to do with computer, anything that drives a benefit from computer. It's basically, so if you say anything that have a benefit from computer, it means that will be very, very voluminous. So for that reason, the computing body now decided to now classify the computing into 5 categories, so that each one will now have its own focus. We have computer science, we have software engineering, we have information system, information technology. So we're going to look at the differences that exist between computer science, software engineering, IT, IS, and CE, so that when you are carrying out your research, you'll be able to know exactly. Because if you are carrying out your research, or you are pursuing a degree, let's say a master's or PhD in computer science, so your contribution must come from computer science. The same thing, PG certificate. If it is in IS, from information technology, if you are not conversant with the differences that exist among this discipline, you end up writing a thesis that in IS while you are claiming you have finished computer science, or you end up writing thesis based on computer science, but you'll be thinking you are writing thesis on information system or information technology. So you see, that is why it is very, very critical for you to be able to understand the differences that exist within this 5 discipline in computer science. So when we say computer science, it's a foundation, is the foundation and theoretical background of algorithm, of which has now been extended now to robotics, intelligent system, bioinformatics, and database, networking, computer vision, and so on. So that is what a computer science is. They will now have software engineering. Software engineering is being derived from computer science, and it deals mostly on developing complex software, so that can be able to have an efficient, effective, critical software that is reliable, that is reliable, and it is also cost effective. So the focus mainly is in development of software, especially a complex software. So when you are talking of computer engineering, it deals with the design, creation of a computer system, including computer-based system like laser machine and X-ray machine, MRI, and let's say surgical equipment. All these are computer-based machines. Then we also have the computer itself, which is the conventional computer that focus on the processor. So before now, when computer science, when computer was using, but later on, with the coming of a processor, then electrical engineering is being removed from computing, and then we now have what we call computer engineering because of the advent of a processor. So, and we say information system. Information system mostly deals with the combination of IT solution and business information. But they see technology as a platform for generating information productivity. That is what information system is. It deals mostly on information that flows within the system than the technology itself. They will now have information technology. Information technology have two different meaning. The first meaning, we can also call computing as information technology. And there is also second meaning that is a department within a discipline within the computing. So it has two meanings. One is the general name for computing. It's synonymous to either you say computing or information technology. And the second meaning is that it's a discipline within the computing. So information technology mostly it comes up as a result of using computer in organization to be able to improve their productivity and within the organization. So because of the usage of the computer system, staff that they will make sure that all systems within organizations are working appropriately, and there is necessity they fix it so that production or working within the organization have not stopped. So because of that, university now started to create a discipline as an information technology within the university. I now been embedded into computing to be one of the disciplines in computing. So in information technology, it looks at exactly what are the modern computer systems that comes up that can be able to replace the one that is in existence, or what are the current computers that just comes up, and they can be able to now compare the performance with the system that just been developed, but don't be released in the market, and the one already existing in the organization, to see whether they will advise the organization to change their system so that it can improve their productivity, or they can be able to check and see whether the information goes with the current trend in the IT world. So these are basically what IT normally looks at. They make sure that the system within the organization work properly, and if there is an upgrade, they ensure that they upgrade to the new system to improve the quality of production within an organization, or the quality of services being rendered by organization. So basically, these are the differences that exist within these five disciplines. And I take all, as I said earlier on, I said all the explanation are based on ACM curriculum. That is where I got all the information, the differences that exist within this discipline that makes up computing. So this is just a table that I created to just give a brief or a summary of the difference that exists within these five disciplines. This is very, very critical, so that when you are writing your thesis, conducting your research in computer science, you'll be sure that this research you are doing is in computer science, and your contribution must come from computer science. Likewise, software engineering, computer engineering, information system, and the information technology. So if you look at the table, you find out that computer science is mostly taught for new method of computing. So these are the major core life. This would large, as I mentioned before, the development of a complex and so deals on development of this core component on the development of a software. And this software engineering has a difference with the conventional engineering that we have. See, with the conventional engineering that we have, because conventional engineering mostly deals with a with hardware, unlike the software engineering that deals with software. Then we have the computer engineering. Computer engineering deals with the design and the creation and the construction of the hardware system, and then embedded and software. And then it also deals with computer-based systems. As I made mention, I'll give example of MRI, laser machine, X-ray machine, and surgical equipment, brain box. All these are computer-based and computer-based and machines, or computer-based and technology. So then we look at information system. It deals more on it deals more of the information that flows within the technology than the technology itself. The information technology, it combines the information and the technology, but it works more on the technology than the information. So this table, I created a table to give just a brief and overview of to show the differences that exist within these five and computing. Research means, we can say research is just an accumulation of scientific knowledge. If you accumulate a research, it leads you to accumulate a scientific knowledge. And research, when we're talking of research, normally it's systematic. A research have to be systematic. There are different approaches to conducting research depending on the discipline. That's why we are banking on computing here instead of the computer on the computing. The research method of which you can be able to apply when it comes to ethical rule that this is the general that you must follow, but at least there is a guide that when you follow, you'll be able to reach your target goal. Then research has to follow a scientific method of inquiry. The method have to be scientific, meaning that you have to be based on fact, not based on rumor. Everything have to be based on fact. And research is non-linear. You can start your research. You can start your research up to the end of maybe 90%. You'll be able to see something that you need to come back and start afresh before you now move. So it's an iterative process. It's not something that is straightforward. If you are conducting research and you find out that you are working straight ahead from one step to another, straight, that shows that a research problem that really what is named as a research problem, iterative. You move to the left, move to the right, move to the left. So that is why by the time you write your proposal, before you graduate, you see the proposal have become something else. So let's look at these two images. This is M.Sc. or PhD proposal, and this is after your graduation. It's just an image for you to be able to see how the reality of what research is. As I said, it's a non-linear and based on your own perception. By the time you graduate, you find out that a lot, even sometimes even 80% of your research. That's why I give example of this with these two images to see just a typical. You have a typical look at the beginning of your research and how it may likely look out after you may have graduated. So when I say we now have research in these different areas, computer science, software engineering, IS, and so on. So if you are conducting research in computer science, meaning that you have to deal with the issue of algorithm, database, network, intelligence system, computer vision, bioinformatics, and so on. So if you are working on the hardware, just on the hardware or embedded software, like processor, it can be embedded software, it can be an X-ray machine, it can be a surgical machine, it can be MRI, and so on. All these are computer-based system. Then software engineering, then definitely the work have to be on software engineering, whereby at the end of the day, when you talk of software engineering, it doesn't mean just, some have the idea that when you mention software engineering, you just write code. It's far more than just writing code. There are a lot of issues. Some of you may have done software engineering in their undergraduate. They know what software engineering is. So software engineering is not just writing code. It can be issue of requirement, modeling, testing, software architecture, and so on. So if you are dealing with information system, it mostly deals with the issue of information that flows within the within the technology, like information retrieval, sharing of information security, information theory, and so on. So all these are part of information and system. So that is that. So now let's look at literature search. So if you are conducting your research, so what to do, definitely once you talk of research, the next thing that comes to your mind, where will I get the literature to read so that I can be able to see what I can come up with. So if you want to search for literature, don't go to anywhere to search your literature. There are what we call, there are specific places. There are specific places, we will talk on that in the next 2 or 3 slides. There are specific places where you Google Scholar and start searching for material. You can go for Google Scholar, but not now. If you want to start searching for Google Scholar, wait until you become established a research before you start working Google Scholar. Because by then you will have been conversant with all the credible sources of literature. But as a starter, I advise you don't go to Google Scholar or Google to search for literature. There are specific places which we are going to discuss it on where your use will determine the quality of your M.Sc. or your PhD. So if you are looking for literature, you have to look for a credible literature, good literature that can stand the test of time. So a literature that globally it has been accepted within the research community that yes, this is a credible source of getting a literature. So what are the steps that you need to do in order to conduct a search and you search for credible literature? So now, before we move on, let's now look at the features of good research and features of bad research. So these are 2 features here: good research and then bad research. Then number 1 is issue of data. Data is very, very critical when it comes to research. You must make sure that your data is of high quality as possible. And you need to, and there should be no incomplete data. Don't be hasty in thinking. You need to avoid plagiarism, falsification of data, falsification of result, or concoction or manipulation of data, manipulation of result. All these are bad features of a research. Then a good research have to base on others' work. That is what literature review now comes in. That most of that literature also, it matters. Where do you get a literature to be able to drive your problem from? So you need to have sufficient data, appropriate data sources, and you make sure that your result can be replicated. By the time you finish your methodology, you now write it systematically. Someone can be able to do analysis of your results, and your conclusion must be based on the data. No plagiarism, and you need to have, and your good research at the end of the day normally generate another problem for other researchers to be able to solve it. So let's look at computing and activities. So these are activities that you can be able to carry out research in typical in computing, the literature, to get a research problem. Then how do you get a research problem? Is through literature review. You can get it. There are other sources like observation, or there are already existing problems that you can just go ahead and then you start solving the problem. But the core, the major source of research problem is literature review. The problem with existing, there are existing problems that exist. You only need to go and then you start solving it, which is very easy at the beginning. But there is no guarantee that you don't have the guarantee that there is no somebody somewhere elsewhere is solving the same problem. If you're not careful, before you reach half of the research, somebody might have finished the work and published it, the same problem you are solving. That's one of the disadvantages of the problem that already exists. Also, sometimes it's based on observation. You can observe a certain machine and see how it behaves, and now be able to detect a problem that common with students. Very common. You see a student telling you that he's looking for a research. It is when you get a research problem, then you are going to use the research problem you get, use that to coin your title. So you now have topic. Then how do you get a research problem? You must do a thorough literature review. Or you get use the existing problems, now go for research design, and it is a research design that will determine the type of data you collect. When you collect the data, then the analysis. The analysis also differs. It could be through algorithm, it could be through questionnaire, it could be through interview, and so on, depending on the type of question or the type of data that you need to collect. Then now get your findings, and then future works. So the next speaker will give you details on how all this data analysis, data collection have been done. So the next speaker will give you, including case studies of these different computing disciplines that I explained in the previous slide. So let's look at the academic database. Sources, as I said, you go for academic literature. That is where you are going to get a credible literature. So academic database is a central collection of information that is mostly used for conducting research and writing. And they index a credible journals, conference proceeding, books, edited books, monogram, short communication, data the editor, and so many other even data. They also publish data in academic database. So you go to academic database and then get your literature, and you start reading before you be able to now carry out a systematic literature review that can be able to lead you to be able to establish problem from the literature. Then you now see how you can come up with a methodology to solve the problem. So let's look at this academic databases. So an academic database searching, normally you find articles in the, you go and then you find it. So let's now look at this academic database. And there are this academic database that are into different categories. They will have academic database that comprise all discipline, and have academic database that are discipline specific. So we're going to look at those academic database that comprise all the discipline, including computing. I want to look at academic database that are dedicated mainly for computing discipline. So this is that is well accepted within the research community around the world. So we call it Web of Science core collection. Web of Science. So this Web of Science is a collection. It's a collection of document. Collection of document from different disciplines, including computing. So if you are searching for literature, you can see the interface, very simple. But by the time you start searching, that's when you know that there is a lot of work that has been done at the background of this academic database. We call it Web of Science. So you all you need to do is to type your keywords, and then you click search. You see a lot of documents that will come from credible source. Anywhere you write if you write your literature review, establish a problem from documents that you are able to source them from Web of Science in the research community. They will also have what we call Scopus. Scopus also is an academic database that also houses a lot of documents from different publishers. So if you are searching for literature, also the discipline, the document, the discipline that have been indexed in Scopus is all discipline, including computing. So you can search your document in Scopus database to have a literature that you can be able to use them in your research. So let's look at the first two. They are from general and discipline. So let's look at those that are mainly it's academic database that mainly index literature from computing. So if you do your searching here, get a relevant literature, and then you are good to go with your research. So ACM, Association for Computing Machinery, as I mentioned when I was discussing what a computing is and the discipline that comprises and computing. So next we have DBLB, Computer Science Bibliography. This is also academic database that mainly index literature from computing. Just don't mind the name. You can see computer science. It is computer science. That's the name, computer science. But it indexes literature from all computing, computer science, computer engineering, software engineering, information technology, information system. All literatures are being indexed here. So that is why you need to focus on the database and also focus on computing and literature. Except the first two that I just mentioned, because the first two, those are the top global academic database that all researchers respect, all top researchers in the world respect those two academic databases. So you look at them, then you now look at discipline specific. So we now have EI Compendix. EI Compendix, it indexes engineering, and literature. But as we know, computing and engineering, if the research is wide advanced, they are normally interweaving. So you find a lot of computing and literature in EI Compendix. So you need to start EI Compendix to have some literature that you can use in your research. Then we also have Science Direct. And since Science Direct is publisher-based, it all comprises all discipline and is one of the credible academic database that we have. So you can also have IEEE Explore. IEEE Explore, it indexes literature from science, technology, and education, including computing. So as a result of that, you can go to IEEE Explore and then search for literature as long as you are working. So we also have Springer Link also. It's publisher-based, it's owned by Springer, which have a lot of literature from different disciplines, including computing. So this academic database I'll just show you. Those academic databases are highly reputable academic database they are highly respected within the researching community. So let's look at the computing research process. So if you look at the screen, you find out that this is a process of a research, and you can see the first where you start your work is from literature review. So from the literature review, you can be able to now establish your problem, or you now have a conceptual framework. So from problem statement, that will determine which type of data you collect. Whether you conduct a survey, you do a design and creation, or you are going to conduct experiment. So, or conceptual framework, whereby you need to deal with case study or ethnography, grounded some theories, or you need to deal with some action and research. Then how the data will now be generated? Which method are you going to use now to generate the data after the strategy? Then that will now show whether you are going to use questionnaire, observation, document, and so on. Then the data analysis could be either quantitative or qualitative. It depends on the research, and it depends on the research. So the outcome you either have a framework, model, algorithm, system, or application. So if you look at engineering is there, software engineering is there, computer science is there, information system is there. So you can see all the 5 disciplines. You can go through this depending on where you are coming from, which of the disciplines you are coming from. You can be able to come out one of these and 5 outcomes. So that is that. So when you are doing your master's or PhD, normally at the end of the day, you now have a committee that will evaluate your thesis. You now have your supervisor. The supervisor is it has 2 phases. Number one is your number one biggest enemy, because he always asks you to add, he suggests you to add more work on what you have done. But at the same time, the supervisor is the strongest ally, is your own strongest ally that in the committee. They're just there, no opinion, to make sure that there is a users we are, they have, and there is donuts, and there is drinks. That's all finished. They don't have any opinion. Those are gurus that they have seen everything. They also have some advisory. Those ones, they are critical people that maybe they have bitter rivalry on with your supervisor. So they always argue opposite of what you present. If you present A, they will argue that it is B. They always argue opposite of what you have. They also have you can also have a strong man, a gentleman, a nice guy that has no opinion. He's just there on the panel. And in the panel also, there are some young lecturers where you can have some assistant professor or a new senior lecturer that he just graduated PhD last year. Is also in the committee. You'll be shivering. You'll be looking at. I was there last year. Here and now I'm in this side. I was on the other side. At the other side, just 1 or 2 years ago. We'll just be there, just shivering, looking at what the examiners will be doing. So this is just a joke, just to show you how those panels are normally being composed. So with this, I think I've come to the end of the presentation. Thank you very much, and let's have a question and answer.
Thank you very much, Dr. Haruna Chiroma, for a wonderful presentation. There are asking for the recording of the lecture. The slides and the recording will be made available via our YouTube channel. We'll provide links for you to download the slides and to watch the video. of the presentation, inshallah. This is time for question and answers. We have about 8 minutes before we go to the next speaker. So if you have, someone says my microphone is echoing. Is everyone hearing echoes on my microphone, or is there a person? My mic cracks. Okay, I'll put on some earphones. Maybe it will be better that way.
Okay, hopefully it's much better now.
Yes, it is better now.
Okay, thank you very much. So we will, if there are questions, then we will tackle a few now. Otherwise, we go to the next speaker.
Well, my advice is probably we delay asking the question, given that we have already been ahead of time by almost 10 minutes. So maybe we just compile all the question and then answer them on a go. But I don't know whether Dr. Haruna will agree with me on this.
Yeah.
Yes, it's okay. It's fine with me.
Okay.
So we're very sorry for this. Yeah, for change of the schedule is just because of the timing.
True. Dr. Aisha, you may share your slides and start your presentation, please. You have 30 minutes also.
Okay, thank you very much. Let me do that. Can you all see my screen, please?
Yeah.
Yes.
And can you hear me very well?
Loud and clear.
All right, perfect. Okay, thank you very much, and good afternoon in Nigeria, good morning around here. My name is Aisha Ligombe, and I'm an assistant professor of computer science at Towson University in Maryland. So before I begin, I want to thank you all for coming to this seminar, and also to the organizers of this event for giving us the opportunity to share our experiences, skills, knowledge with you all, and hoping that with Dr. Haruna's presentation and my presentation, we're going to kickstart a discussion on how to begin research, how do you structure research, and the learning needs you require before you can complete your research. Now, my research is titled, or my topic today is titled, How to Research a Computing Perspective. And this is my outline. Before we get deeper into discussing how to perform a research, I think it is only reasonable if we can clearly define what is research, and then establish the importance of motivation in research. Now, what is research? Dr. Haruna has defined research as a systematic approach, and this is a definition given by Oxford Dictionary. Research is a systematic investigation into and the study of materials and or sources in order to establish facts and reach new conclusion. Now, research is often seen as a quest for knowledge, but unlike our traditional, our knowledge source from traditional classrooms, research is an inquisitive, question-seeking, and often problem-solving process that leverages provable scientific methods to drive new to solve some present societal problems. Now, knowing what is research, the next thing is, why are you conducting your research? What is your motivation for research? Now, generally, motivation is a desire or willingness for someone to do something. And oftentimes, people have so many reasons for conducting a research. It could be based on personal experiences, interests, trials, tribulations, just that passion to change the world. Now, whatever your motivation is, it is highly very important to identify that motivation early on in your research, because research itself is a journey and things can get extremely very, very tough. In fact, there's a publication that mentioned, at least in North America, that doctoral research attrition, which is the dropout rate for doctoral students, is about between 40 and 50%. Now, Why motivation is important is whenever things are going to get tough as you begin your research, whether you're a novice research or an expert research, but your ability to be able to pick up and move on is when you have really good motivation for starting research. Now, having said that, let's talk about the different research methods. Generally, there are so many classification and perspective to research, often from the type of methodology of the research. From basic to categorization ranges from basic to applied research, qualitative to quantitative, descriptive to exploratory, etc. Now, as Dr. Harun mentioned, this different classification could be applied to the different kind of discipline and subdisciplines that we have in general, and also very specific to computing. Now, because this presentation is specific to computing research, I'm going to elaborate more on this broad classification of research, which is in terms of either basic research or applied research. Now, basic research is called fundamental research, and this is a research that is aimed at expanding knowledge, creating new theories, or even expanding or modifying the existing theories. While applied research, on the other hand, is focused on developing or using solving problems that leverage some empirical evidences. Now, let's take an example of a basic research. So think about, in computer science, there are already existing, algorithm for memory allocation. So if you're developing an entirely new algorithm for, memory allocation on a new embedded system, that may be classified as you're developing a new symmetric algorithm for cryptography, right? So that may be termed as a basic research. Now, what about an applied research? In applied research, we're leveraging existing knowledge or empirical evidence to solve some complex problem. Let's assume an example here could be you're developing a new model for facial recognition, or you're developing a new model for intrusion detection on wireless networks. So that could be termed as an applied research. Now, due to the fact that computing research is fast evolving field and it's the driver of the 21st century economy, the need and desire to innovate has made these two broad areas of research distinctively different, but also equally very, very important. Now, while in some fields of science, such as maybe medicine, basic research is often seen as an academic exercise, while applied research is seen, as a research and development R&D part of a company. However, in computing, the scope of both applied research span across academic, industry, and government. In fact, there's often a huge synergy between, or synergistic relationship between all of the three. An example here is Facebook, for instance, is putting a lot of money in their R&D towards developing algorithm for detecting fake news. At the same time, for instance, in the United States, the government is putting a lot of money through, for instance, NSF, secure and trustworthy cyberspace, in developing the same, algorithm. I'm not going to say the same algorithm, but geared towards the same objective of developing techniques for detecting Facebook. And they're all funding, whether they're funding industry or they'll be funding academic institutions to perform those research. So as we can see, this huge synergy over the years has resulted in an extremely tremendous achievement in computer research. And over the years, we've seen a lot of advances in computing, from quantum computing, artificial intelligence, cybersecurity, wireless network, interconnected devices. This area of computing is increasingly becoming very diverse, and it is changing the world by the minute. And still yet, there are so many untapped opportunities, both in theory, in basic and applied research, or in practice, basic research or fundamental research, or in practice in applied research to really now, when identified whatever is your motive for going into your research and having identified an area of interest, now where do you begin? How do you plan your research? So I'm going to introduce you to a model called the sense-making model. This is a model proposed by Halls et al. In 2006 in their paper titled Research Methods in Computing, What Are They and How Do We Teach Them? And this is a paper that was published in Computer Science Education Conference, which is part of an ACM organization. Now, in this paper, the authors proposed a model called the sense-making model, which is a framework that is grounded in questions rather than answers. The authors proposed the sense-making model is designed as an iterative cyclical process that is made up of 4 interconnected questions. And the questions are, this is the questions for which the researcher now needs to ask his or herself, as they, take up a research project. What do we seek to achieve? That's the first question. Where does the data come from? What do we do with the data? How do we achieve our goals? Now, those are the 4 interconnected questions that form an entire research plan. Now, the authors of this paper argue that, this new model that they propose will help especially novice researchers to understand the requirement of their domain, help improve their creativity, and it's going to put them in control of their research work. Now, the authors illustrate this model using 4 quadrants. So, and again, I apologize, the image here might just be a little blurry. I had to screenshot that from the paper. So it has 4 quadrants. And in each quadrant, we have one of the 4 questions. So in the first quadrant A, we have the first question which asks, what do we want to achieve? And then quadrant B asks, where does the data come from? C asks, what do we do with the data? And then finally, D asks, have we achieved our data? As you can see, this is a cyclical iterative process. Now in the first quadrant, a researcher needs to ask his or herself, what do I want to achieve? Now, at this point, the assumption is you already have a motivation for research. You already have identified an area of research. And let's take an example. Let's say you want to do something, you're kind of, personally motivated to do something in cybercrime investigation, right? So what do you want to achieve in cybercrime investigation? First, you need to figure out what is happening in that field. What is the state of the art? What technology are, what techniques currently exist and how do you improve on that? You probably have to evaluate existing systems and compare, existing systems and then do an in-depth literature search. Now, this here mapped to what we traditionally call the problem definition, where you identify a problem, find a niche, and then develop your research question. Now, that will lead the researcher from quadrant A to quadrant B. Now, in quadrant B, the researcher has to ask the question, where does the data come from? Now, in this quadrant, there are 3 things that a researcher needs to identify. What exactly is the data, where to collect the data, and how to collect the data. Now, depending on, again, the subdomain of computing, as Malang Harun mentioned, CS, CE, IT, IS, software engineering, depending on the subdomain you're currently working on, your type of data may be completely different. Your type of data may be qualitative data, quantitative data, nominal data, ordinal data. It could be memory images. It could be network packets. It could be, instruction sequences. It could be anything depending on what exactly you're working on. So A determines the kind of data that you'll be working on in B. Now, then where do you collect the data? Again, that is very subjective. It could be in the field, it could be in the laboratory, it could be conceptual data, it could be system data, again, depending on your field. How do you collect the data? Is it by reading, observation, asking, measurement, experiment, modeling? Again, very, very subjective. Now, this is mapped to what traditionally we call the research data and, the part of research that is called the data collection phase. Now, after identifying your data and collecting your data, the next phase is, what then do you do with the data? Now, in what you do with the data, this is where you now take your data, process your data, examine your data in order to identify patterns, come up with expressions, identify trend, develop, multimedia frameworks, taxonomy, etc. This is where you take the data, parse the data, and use some data analysis methods. Now, again, the type of analysis method you're going to use is going to be completely subjective. It's going to be very relevant to your area of research. And again, that fits back into quadrant A, quadrant A, what do you want to achieve? Now, after this quadrant, then that will lead the researcher to quadrant D. Now, in quadrant D, the question is, have we achieved our goal? Now, your data analysis will result. Here you want to examine your result, you want to evaluate your result, you want to do some maybe performance metrics, and then do some examination and see if you can draw some conclusion. And then can you use this conclusion to see if now you have achieved the goal that you set up to achieve in A. And this is what we normally map to our evaluation and conclusion in our research. So as I mentioned at the beginning of the sense-making model, that this model is an iterative cyclical approach, meaning it's possible by the time you get to D, you actually have not achieved your goal. So that means you have to move back to A and maybe refactor your question, or maybe there's an issue with your data. Maybe your data is too small. Maybe you need to go and improve on your data. Maybe the data collection process has some fault. Maybe you need to re-examine things. Maybe you need to use a different data analysis model. Then you have to come back to D. And oftentimes, whether knowingly or unknowingly, in our research work, we have all gone through this cyclical 4 quadrants multiple times before we get a final result that jive our quadrant A. Now, this is very hypothetical, so I want us to take a case study and look within the case study whether we could, a research work can actually fit into this 4 quadrant. So in the first case study, I want us to take, so I looked up a paper. My research expertise is in cybersecurity. I do more applied cybersecurity stuff, but I wanted to take something, in a different field. So I looked up a paper, and this paper falls into HCI security paper in kind of an overlapping field called usable security. So this paper is titled, "I Have Too Much Respect for My Elders, Understanding South African Mobile Users' Perception of Privacy and Current Behaviors on Facebook and WhatsApp." This is a paper, I think the authors are from Princeton and University of Chicago, but the data was collected in South Africa. Now, let's put the entire paper into those 4 quadrants. The first quadrant, remember, asked the question, what did the authors seek to achieve, right? So in this paper, the authors, the problem they are trying to address was they want to investigate how resource-constrained low-income mobile users perceive and manage their privacy on social media. So the whole research is built upon trying to understand human perception of social media, and specifically tailoring to the study to participants in South Africa. Now, with that in mind, with that goal in mind, where does the data come from? Of course, because this is a human study, they decided to conduct an in-person interview with mobile social media users at Cape Town in South Africa between November 2018 and 2019. And because this is a human study, it has to go through an IRB approval. So now they got the data, which is going to be in-person interview, and this is going to be qualitative data. Now, what did they do with the data? They transcribed some of this interview because some were conducted in Swahili, and then they used structural coding to map the interview to some codes, and then perform thematic analysis to identify trends and patterns. Now that is what they did with the data in the 3rd quadrant. Now, finally, after all the transcription, coding, and analysis, have they achieved their results? Yes, the authors claim at the end of the paper that they found a couple of themes that emerged. One of the theme is users are more mindful of their elders, and compared to whether platform steals their data. And they also found that participants lack knowledge of privacy protection settings. In addition, to identify there are a couple of limitations. The sample sizes are very small, and the demographic is very narrow. So this is not necessarily an adequate representation of the entire population. So as we can see, this is an entire research work, and this paper was published at TUSNEXT. It's an entire research work that is mapped into those 4 quadrants, it's sense-making model, and we can, it can easily, even if you're new to research, you can easily see an entire research workflow from these 4 quadrants. Now, let's take this 4 quadrant again and map it to an applied research. So I want to use my research work as a case study here. This is a paper that we published in EXEC, which is also an ACM conference in 2020. It's titled App-Agnostic Post-Execution Semantic Analysis of In-Memory Forensics Artifact. Now, this is a digital forensics research that is aimed at, we had 3 objectives. The first objective was we wanted to develop something that leverages userland memory image, and it has to be app agnostic, and it has to, our mechanism has to find provenance and relationship between in-memory objects, so we can use it for semantic analysis in cybercrime investigation. So that is what we seek to achieve. Now, where did we get the data? So we got our data because there are no available data, so we had to create data. So we run multiple different applications on, a simulated environment, and we dump them. And then we collect we recover the data using Droid Scraper, which is again another open source tool. So that is our data. Now, what did we do with the data? Because we wanted to develop a technique for userland memory forensics, we developed, so our technique was called OAGen, and it leveraged a known analysis method called points to analysis that find a relationship between pointer references. And so our technique called OAGen was able to create graphs using point to analysis. And then we had another set of algorithm called the semantic analysis algorithm that uses graph theory to find path within in the graph between nodes, and then find context and scope within the graph for some data of interest. And then we test this tool against all the memory images. Now, at the end of this research, have we achieved our goals? Yes, we did, because OAGen was developed and you can use it on any kind of memory image. As long as it is an Android memory application level image, you can use it without knowing the application logic. And we conducted a couple of case studies to show that this tool can actually be used in real forensic investigation. We tested on WhatsApp. So if you've used WhatsApp before, you know that you can use WhatsApp to delete message from everybody, so that message is finally destroyed. But we can leverage this method to actually recover the message and find that the message is actually deleted because of the provenance. So with that, we have achieved our goals. So again, going back to the sense-making model, the model is a way of organizing your research plan. And you can take, starting from quadrant A, identify your goal for the research, moving to trying to figure out what exactly is your data. Then after getting the data, what do you do with the data? And finally, drawing up conclusion and see if your conclusion matches what you seek to achieve. Now, with that, are we ready to begin research? Maybe there is more, because the work plan just gives you an opportunity to really kind of easily illustrate your entire research work in like a plan, right? So this is like me, I'm writing a program. I needed to have, for instance, at the initial phase, I need to create a flowchart, right? So I put in a flowchart, I have a plan, but is that enough for me to create a program? Probably no. I need more stuff. Now, what do I need? According to the work of Blackster in 2010, Blackster say every researcher start at a point where you have what is called a current knowledge. And that is true. If you just graduated your undergraduate degree in computer science, you have some knowledge in programming. You have some knowledge maybe in system design. But do you have everything that it takes for you to actually successfully complete a research task that you have in mind? Right? So if you identify your workflow, like for instance, let's assume the first workflow, do we have everything to complete that exact type of research? Now, the gap between your current skills, resources, and knowledge to the successful completion of your research, Blackster termed that as your personal learning needs. Now, this personal learning needs is the skills, resources, and knowledge that you need to acquire at every phase between the start of your research and the successful completion of your research. Blackster mentioned that you cannot complete your research without acquiring all the relevant learning needs. So that means as a researcher, the first thing after identifying your motivation, your area of research, coming up with your workflow, even if it is just a skeletal workflow, then you need to identify, what do I need to know? what skills do I need to add? What knowledge do I need to know before, for me to get to the completion of my research? So Blackstone called he proposed a blueprint called the development plan. And this blueprint will enable you to meet your identified needs by assessing the adequacy of your current skills and knowledge against the research task. So in this development plan, a researcher needs to identify their learning needs in terms of skills and knowledge. They need to identify how to achieve the needs in terms of access to resources. They also need to put in timeline because, anything without a timeline, definitely, that there's no plan to that. Now, let's take, so again, this is theory, this is hypothetical. Let's take one of the examples I gave, one of the case study, and I want to take the South African case study. Let's take that case study in the sense-making model and infuse a development plan into that. So let's start somewhere here. We have a column for our knowledge and skills. This is what we identified that we need to get. Then let's identify a couple of resources that may help us get that. And let's try to see if we can put in a timeline. Again, the timeline here, we should not care about that. It's completely subjective. But if you're doing it for yourself, I will recommend that you definitely put in some timeline. Okay, so in the first quadrant, am I the only one hearing the music coming in here?
Coming in, I'm trying to find the person and unlock the.
It's Usman Garba.
Usman Garba, can you please mute yourself?
Maybe you mute everybody. Can you just mute everybody? Mute myself.
No, it's not. Who is?
Mala Yusuf, can you mute everyone, Mala Yusuf? If you can mute everyone.
Okay.
Then, yeah, just mute everyone, and then Aisha can unmute herself.
Okay, let me just go about that.
I think we're good. I think we're fine now.
Dr. Musa, you can mute everybody, please.
Musa, you have to do that.
All right, so I think we're good. We're fine. All right, so so going back to the sense-making model and how we're going to infuse the development plan into that sense-making model. So first is, in your first quadrant, what do you seek to achieve? Here you have to identify the knowledge and skills that you need. First, in how do you, because in this quadrant is where you identify your problem and pose a research question and then actually select a topic. What do you need? In terms of knowledge, you need an in-depth knowledge in your content area, and you need to identify the state of the art, current research in that area. In terms of skills, you're going to need skills on how to search and find relevant research work. Everything that Dr. Harun mentioned is very, very important in this phase. You have to have skills on how to conduct literature review, how to read a scientific paper, how to read and review and also critique a scientific paper. These are the set of skills that you need for you to achieve the set of skills necessary for the first quadrant. Now, what are the resources? The resources might be, discussing that with your supervisor, meeting, regularly. So your supervisor, again, remember that your relationship between you and your supervisor is kind of an apprenticeship program, right? So your supervisor is trying to kind of, whatever he knows, trying to dump that on you. So that, as you meet regularly, your supervisor will be advising on his knowledge on what is happening. He might just point you to the right direction in terms of state of the art. Do you want to take, do you want to attend a seminar course so you can really understand the content area? Do you want to talk to friends, and do you want to review trends? But more importantly, this is where you want to review related literature. And if you're looking for more recent state of the art work, I would suggest conference publication. But you also want to know high impact relevant articles, which I would suggest go for journal publication and also old conference proceedings. So an example here is in this particular South African paper, they cited a paper which looks like, that's like the father of all papers in that area of usable privacy. And that paper was published in 2009. It has more than 500 citations. And if you're doing literature search, maybe this is a topic for another day, you can actually start from a very old paper, and usually those papers are going to have high citations, and then you can, if you're on Google Scholar, you can click on all the citations and then keep following and weeding out things that you don't need, and that will help you identify all the relevant papers in your area, starting from one of the oldest papers or one of the papers that has already been highly cited. Now let's go to the time scale. Again, I mentioned the time scale is going to be completely, subjective, so I'm not going to even talk about that much. But what is the output here? Irrelevant to the paper that we're talking about, the case study. In this first phase, after identifying the knowledge and skill, they were able to settle on a topic, which is human perception of privacy. They were able to identify a problem, which is privacy in social media is still a challenge, although there's some work, but there's no adequate body of knowledge on how humans perceive privacy. And they were able to get a niche because there was no study that was ever conducted in South Africa. So here we go. They got their knowledge, they got their skill, and they were able to settle on particular items, related to the first quadrant. Now, what about, so going to the second quadrant, where did the data come from? So here, what I just
need to remind you that you're almost 30 minutes. So
right. So I apologize for that, and I'll wrap up in a couple of minutes. Now, where did the data come from? Now, the data here. So what's the knowledge and skills that we need? Because at this point, we will be collecting data, so we need knowledge and research methods, specifically for human study in security and privacy, because you've already identified a topic and you want to narrow it down to very. Then what are the skills? How do we develop a research instrument? What are the types of research instrument, the structure, the design, sample size, etc. Now, again, what resources? Review related literature for review methodologies for existing literature, and very, very specific to human study. Explore sample interviews and design yours, review with your colleague, friends, and your supervisor. Now, what will be the output? At this point, you should be able to, after getting all the knowledge and skills and going through the process, you should be able to settle on. Again, I'm mapping this to the case study. They were able to settle on qualitative research method. They were able to settle on interview as a research instrument, and they were able to settle on size, demography, and the structure of the interview. Now, the third phase, where did the data come from? Again, what knowledge do you need? Because this is a qualitative data, you need knowledge on qualitative data processing technique. You need knowledge on qualitative data analysis technique. And the skills is going to be on data processing analysis software. How do you set it up? How do you configure it? How do you load your data and process? Again, the resources, you can review that. Again, related literature, explore different options, different techniques, and see which one works. Review with your supervisor. And always point back to what you seek to achieve, Quadrant A, to see if the analysis method fit into your research objective. Now, what is the output here for this paper? They were able to perform interview in Quadrant 2, but in Quadrant 3, they translate the interview because some were done in a different language. They did multi-round coding for each interview, and they used semantic and thematic analysis. And finally here, how did they achieve their goal? Now, when you come to this quadrant, mostly it's going to be about skills, not knowledge, because you already have the knowledge on the type of analysis. So here you want to use the analysis and try to figure out if you can draw some conclusion or find some patterns. Again, you want to review related work specifically on thematic analysis, see how it is done, how they generate their result, test your own analysis, generate your own result, draw your conclusion, and repeat where necessary. Now, for this paper, they divided their teams into subgroup. They conducted coding in every group and analyzed the data separately. And then they generate summaries, and they review the summaries after during meetings collectively, and they finally arrive at some conclusion. So before I round this up, I want to give you a task, okay? Whether you're a novice researcher or, of course, I'm a teacher, I cannot round this up without really giving some homework. So whether you're an experienced researcher you to look at this. Write your research idea and identify a motivation for your research. Then use the sense-making model to draft a research plan. And finally, create a development plan that identifies your learning need for the research plan you identified in 2 based on the current skills that you have, knowledge, and resource. With that, that will wrap my presentation, but I want to leave you with some quotes from some giants. This is a quote from John Crisell, who is a known professor, that says, good and sound projects begin with straightforward, uncompleted thoughts that are easy to read and understand. And if your research you cannot break it down into simple questions, then probably you need to revisit your idea. And according to the word of Albert Einstein, if you knew what it was we were doing, it will not be called research. Then think about it. If you have no skills and knowledge to learn in the process of your research, then perhaps it is not research. So with that, I wrap my presentation, and I'm sorry for going over time. Thank you very much, and I'm open for questions.
Thank you very much, Doctor, for your wonderful presentation. We have to, I have to say that we need to thank Gombe State in general for presenting us with these 2 wonderful presenters. We really appreciate your presentation, and we will go straight into question and answers. There is a typed question here from Abdullahi Musa. He said, by the time and either of you could go ahead and answer the question, Dr. Haruna or Dr. Aisha. He said, by the time you come up with a systematic review, what is the minimum journals or papers needed for such review? Is there any minimum number of papers or maximum number of papers that you need to come up with by the time you do a systematic review or a literature review? Dr. Haruna is smiling. Go ahead and unmute yourself. We're not hearing you. You need to unmute, Dr. Haruna.
Hello, can you hear me now?
Yes, loud and clear. Yes, we could hear you, Dr. Haruna. Go ahead,
this
please.
question is, what will I call it? Frequently asked question. This question is a frequently asked question. Even my students, when I'm assigning students, I ask them for literature review, ask me how many papers are they going to review for the literature review. This question almost keeps coming almost every time. Any student that comes, if I can have like 10 students, like 9, they will ask me, how many am I going to review for the literature review? And the question is, if you are doing literature review, you have to exhaust to the best of your knowledge. You exhaust the whole literature that talk on the topic you intend to work on. You have to, based on, you review all the 100. If there are 50, you review all the 50. If there are 10, you review just this 10 that is highly relevant to your focus. Let me give you an example. Let's say there are 20 papers, and in where you are focusing to 15 and leave 5, and say you think 5 is okay for you. Then you are able to establish a problem between that 15 papers, and then you are able to now query your topic with the research problem that come up from the 15 papers, leaving out the 5 papers. Then how are you sure that the problem you are solving is not among those 5 papers that you didn't review? That is why, if you are reviewing, you exhaust the whole papers that are within that particular, that are within your scope. You exhaust the whole papers based on your ability. You may say, how will I know that I've exhausted the whole paper? All these academic databases I show you, you have to go you have to search all the academic databases. After you do that, maybe by the time you finish searching this academic database, maybe by that time you will have been conversant with a credible source of literature. So then you can be able to go to Google Scholar. As I said, I always give advice: if you are a beginner in research, don't go to Google Scholar or Google. Start with these credible academic databases. By the time you go to Google Scholar, you'll be able to identify good sources and bad sources, because in Google Scholar, that is why I always advise a beginner to start with the credible sources. So by the time Google Scholar, you're able to understand which one is good, which one is not good. So you try to exhaust all the papers and do the review, and then you establish your problem. To the best of your knowledge, this is all the papers that have been published and you have reviewed on. So when you establish, you also have that confidence that yes, I'm able to establish a problem from the literature. So there is no minimum or maximum paper. You have to exhaust all the papers that are within the scope of the review. I hope I answered your question.
Thank you, Dr. Haruna Chiroma. I will let.
Can
Yeah,
I
go
add to
ahead.
that?
Go ahead. Yeah, go ahead, Dr. Aisha.
Okay, so I'm going to give you the trick that I always use. I don't know the name of the person that asked the question, but this is what I often use. So when I begin a particular, let's say a new research in an area that, I've never done some work on, I will look up some really highly relevant papers, right? So I'll look up like papers that have been cited. So let me just give you an example with the same South African paper. And I actually just started working on usable security, and I've never done qualitative research. So I will dig, and because I've already identified my motivation and, I've already identified what I want to work on. So I'll look for relevant papers in that area and then see, some highly cited paper. Then I will take this as a model paper. And this is what actually my supervisor taught me. If you're starting research before you really get to know your own, before you kind of start putting your own creativity, find a model paper. So I'll look for a model paper, and then I will look at the design of literature, right? What kind of papers did they cite? How did they structure their literature review, right? And then this will give me an idea, like how wide I should, start digging in. And as Dr. Haruna mentioned, this is very subjective from field to field, and again, it depends on your question. But if you take a model paper and then use that as your initial model, look at the way they structure the literature review, the number of papers they cited, how broad they were able to go in their literature review. That will give you an idea on what is acceptable within that domain, right? How deep do you need to go within that domain? Because first, this paper is a respectable paper. It has already been established. It's highly cited, right? So it's acceptable in that domain. So that you can use that as your model, as your framework to kind of see, how many papers, should be enough, or what scope of knowledge should be enough in your domain. I don't know.
Thank you, Dr. Aisha. Yeah, that's great. I'll just tell the speakers that to keep the answers to maybe 2 minutes short so that we can take as much questions as possible. We have 12 minutes until the end of the session. Okay, so there's another question that says, thesis have, okay, before I take the text question, there is a person who raised up his hand earlier. I'll just take a voice question before we go back to, I think, okay, I'll take this one and then I'll take the voice question later. So he said, the thesis have a developed, must a master's thesis have a developed software and researchable problem, or any of the two is okay? Must a master's thesis have a developed software and a researchable problem, or any of the two is okay? Dr. Aisha?
So I think this is from university to university, and I will say is from supervisor to supervisor, of course also from like the different field. So if you're in computer engineering, maybe probably you're not developing a software. If you are in information technology, you might be dealing with technology, maybe you're not developing a software. But if you are in core CS or software engineering, maybe some software development is required. So I will say, look at your research problem, discuss that with your supervisor, and try to identify whether this is what's obtainable in your subdomain.
Okay, Faisal A. Garba, if you are there, can you unmute yourself and ask your question? You've been raising up your hand since during the lecture. If Faisal is not close by, I have set it for you to
Hello,
unmute.
I'm close.
Okay, go ahead, please.
Yeah, so I have some questions. One of my questions is that, though one of them has already been answered, that is how many literature will someone review and say that it is enough before coming up with one's proposal. Now, one of my questions is that, say I'm currently reviewing works. Let's say I started from, say, 2017 to 2022, because as of now, we may have some papers that are going to be released 2022. And then I identify some weaknesses within, say, 2021 papers, and I come up with idea to address those weaknesses within those literatures. That is 2021 literatures, because they are recent works. Identify some weaknesses that I want to, and then I come up with idea that I want to use that idea to address those research gaps. Then you know that where say it is a computer science, I have to implement, I have to develop a software that is to implement my idea. And that will, of course, it will take me time, okay? So now since I finish up, let's say it takes me a year to finish up, let's say 2022, by the end of 2020, I'm going to evaluate my work. I have improved, or I am going to evaluate my research work against new research papers that have been released in 2022, because I am improving 2021 work, and my work I finished my work in 2022. So am I going to evaluate my work against that work, that research paper I have improved, or against new papers that have been released in 2022? So that is my question. Thank you.
Thank you, Faisal. Dr. Haruna Chiroma, can you tackle that, please?
And the problem, he was breaking. I could not hear him completely.
So what he was saying is, his question was, if he tries to evaluate papers from 2027 and he is doing work in 2021, which he plans to publish in 2022, and then just before publication, there are some works that have come up which are similar to, or which are close to what he is doing. Is he going to evaluate his work based on the gap he saw back in 2017 or 2018, or he has to evaluate his work against the newly published work in the area?
Oh, okay. If I would understand him, maybe but the problem is not talking specifically.
It's just about deciding the baseline you compare your experiment with.
You know, because when you are talking about research, it depends. Please, can you be specific?
He's just talking about how do you decide the baseline?
Developing software, or developing new components for a particular.
No, he's talking about baseline. Yeah, go ahead, Dr. Aisha, if you understand.
Yeah, because I heard the question. I think Mala Haruna missed the question. So I'm going to tell you from experience, if this is for a master's or a PhD thesis, maybe evaluating against 2020 work may be acceptable. But if this is for conference publication and journal, your reviewers will not care about when you started your work. They will, all they know is there's an existing work at the time that maybe right before you publish, right before you submit. And if those work are already out there, they will want to see your evaluation against existing work, like current state of the art. Now, usually reviewer for different panels and stuff, and if, let's say, the time between when you submitted and that, let's say that was a work like 3 months ago that just published, I mean, that will not be count against you. But if, let's say, the work has been there for like maybe 10 months and it's an existing work, and you if maybe the work got a best research paper in a conference, so everybody knows about that work. So it is expected that you're going to compare your work against that, because that's the state of the art. But mostly for master's and PhD thesis, because that's a process that takes much more longer time for you to accumulate your entire work, then you may not be penalized for comparing your work work against much older work. I don't know if that answers your question, Faisal.
Thank you very much, Dr. Aisha. I think we'll go to the chat question. And Aminu Abubakar Ali is saying, between conceptual framework and theoretical framework, which one is more important in scientific research, or do they mean the same thing? Dr. Haruna, do you want to answer that, please?
Okay.
Between conceptual framework
and theoretical. This mostly yes, conceptual framework and theoretical framework. This theoretical framework, let's see where it falls in. It falls in mostly in information system. That is where they mostly deal with this issue of theoretical framework. So this theoretical framework is the establishment, because all, maybe if you want to establish, let's say, a hypothesis, you need to establish it from the literature. And the literature also have to have a theory. You must bank your work on a particular theory. You have to be able to come up with your hypothesis before you do the testing. Then for conceptual, the conceptual framework can come from the computing background. I can also come from the social science, but you know I cannot talk on social science, I will talk on computing. The conceptual framework is that, for instance, now let's say you finish literature review and you are able to establish a problem. So you need to concept the idea you concept, the conceptualized idea on how you go about solving the problem, maybe putting it in the word, maybe flow chart or a block chart, or give me a pictorial. That is your conceptual framework. That is the process you follow to solve the problem based on the concept that you are able to come up with. But the theoretical, as I said, mostly is information system that when you are developing hypothesis, you need to rely on a particular theory to drive your hypothesis from before you do the testing. If there is no theoretical backing, it's not going to be accepted, because, so for instance, now there are books that when you are reading them, you see a lot of theories on information system theories, a lot of them. So when you are doing a work, you need to be able to establish your work from one of the theories, one of the relevant to your work. Establish it. That is where the theoretical framework now comes in. I hope I answered your question.
Thank you very much, Dr. Haruna. We'll take the last question. Apologies, there are many questions on the chat and there are some people raising up their hands, but I will allow Muhammad Lord Tijani to unmute himself and ask the final question of the session. Muhammad Lord Tijani, are you there? Okay, I will then go to Musa Umar Musa Umar. Can you go ahead and ask your question, please?
Yeah. Good afternoon, everyone. I wish to appreciate the presenters and the participants for organizing and attending this program.
Go ahead, Musa Omar. We have only 2 minutes to go, so you can ask your question in 30 seconds and then maybe.
I also wish to ask if there is any WhatsApp or Telegram group for organizing this similar type of the program.
Presentation.
Nice.
Sorry, I'm there.
Please, is there any WhatsApp or Telegram?
Muhammad Tijani, can you please hold on until Musa Omar, we don't have any Telegram or WhatsApp page, but we do have a YouTube page where we put the videos and also we put links to the slides that are used in these presentations. We'll also put the recording there. And unfortunately, I have to stop all questions at this point, and we cannot take any more questions from the chat because we started at exactly 2 o'clock and we want to finish by 3:30. I would like to take this opportunity to appreciate our speakers for the wonderful presentation and to appreciate you attendees. This is the highest attendance that we have gotten since we started this seminar series. More than 100 people joined. We say thank you very much, and please do join us in our subsequent seminars. These seminars are held on the last Thursdays usually of every month, or on the last Wednesdays of every month, and we appreciate you attending. We want you also to be part of our next outing. Mala Yusuf, any words of closure?
Yeah, probably just if the presenters will want to add a word or not, if none of them would like to see anything further, then we can close the day.
No, I'll probably drop an email with you, Malan Sani, if anybody wants to follow up with a question.
Okay, thank you for that.
Dr. Haruna.
What I said, I'm happy to even see the number, because mostly once you talk of anything research, people are normally drag their leg, don't want to comfort. I'm surprised to see this high number of participants. So thank you very much for your time. I hope you see join us again next time. Bye-bye.
So I think there's an important comment here in the presentation. Somebody say, sorry, in the chat box, somebody says, can a session next time be dedicated solely for attendees to ask questions? Maybe the organizers can think about that.
Okay, interactive session. Okay, thank you for the suggestion. It's something that we should think about.
Thank you very much all, and see you next time.